Okay. Hi, everyone. My name is Justin Essery, an assistant professor at Rice University. Welcome to the International Methods Colloquium. The International Methods Colloquium is a periodic online interactive seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Rice University and the National Science Foundation. This week's speaker is Andrew Gelman from Columbia University. His talk is entitled The Statistical Crisis in Science. Andrew's talk will last between 30 to 40 minutes, after which point we will take questions from the audience. You can ask questions by emailing them to methods.colloquium@gmail.com. You can also, and this is perhaps a bit easier, ask a question using the Zoom Q&A button that appears at the bottom of the webinar window. If you hover your cursor over the window, you should see a Q&A button. For our viewers outside the United States, we recommend using the Q&A box to ensure that we receive your questions immediately. Now I'd like to welcome Professor Gelman to the IMC. Dr. Gelman, welcome.
Oh, hi. I'll have to say I've given a lot of remote talks, especially in the past year or two, and this is by far the best organized ever. You all know what you're doing. Sometimes I like to say that I operate on a principle of division of labor, that I try to describe what's happening in the world and then let other people try to explain it. And it's sort of a luxury as a statistician. Sometimes I think about issues of causality and identification and all that. It's a real concern, but often it's just description alone is challenging enough. And a lot of times people spend a lot of time trying to explain things that aren't even happening at all. So just for example, something I saw the other day, I don't know, there are people from outside the United States, so probably a lot of you aren't going to know what I'm talking about here, but I apologize. We're having a presidential election in this country. It happens every 4 years, and again, you guys probably haven't heard too much about it, but there was an interview I was reading with a political scientist, a prominent political scientist, and the interviewer said, they were talking about the election, the interviewer said, "It is unusual for a two-term president to be succeeded by another of the same party. Will that pattern hold in 2016? And then the political scientist responded that Republicans would have taken back the presidency with relative ease if it wasn't for the many negative qualities of the Republican candidate. And so the argument was that when someone's been president for 2 years, then the voters are ready for a switch. The political scientists referred to the standard fatigue that we see after a party controls the White House for 2 terms. And it's kind of frustrating for me to read things like this because it's as if people have no memory. It wasn't so long ago, the year 2000, Bill Clinton had been president for 2 terms, and then Al Gore won the presidential election. He received more than half the votes. In 1988, Ronald Reagan had been president for 2 terms, and then George H.W. Bush was elected. In fact, if you go back, you can go back to 1876, and you find that there have been 11 elections where somebody had served for 2 terms, and of those elections where there had been a 2-term president, 5 of them, the same party persisted as president, and the other 6, there was a shift. Basically, there was no pattern at all. It's not at all unusual for a 2-term president to be succeeded by another of the same party. So this is very common in social science, that there is a stylized fact that people use and refer to and try to explain, but it's not even true. It's a false fact. And part of the statistical crisis in science, I believe, is that we have a paradigm of science and of social science. And the paradigm we have is that we develop we do studies that are definitive, that establish stylized facts, and then we put these facts together in order to make decisions and try to understand the world. And if you look in, not just like reading the tabloids, Science and Nature and all that, not just, not even like just journals, but even textbooks, the paradigm of statistics is that you have a little study which is like a nugget of truth, like a little, it's like a brick in the wall, a brick in the edifice of science, right? So we just, we do these studies that are supposed to be definitive, and often you just can't. People want something that they can't really have. They want certainty. And I want to talk a little bit about, I'll give some examples and talk about ways that we can do better, but also try to address this puzzle, which is why does it seem, this puzzle that like, why does it seem that we have certainty? Why do people get such seemingly certain results if you can't have it? This is a political science talk, so I was started with this first slide, just a bunch of things that in the published literature people say affect people's attitudes or how they vote. There was a claim that women have different political preferences depending on what time of the month it is. There was a study that claimed that college students with fat arms had different political attitudes than college students with thin arms. A claim that subliminal smiley faces flashed for smiley faces flashed on the screen for less than the threshold of conscious perception could change attitudes on immigration policy. That last one is kind of amazing, because if you think of all the people who are working so hard to change people's attitudes on immigration policy and how hard it is to do, it's kind of amazing that a smiley face could do it. Perhaps fortunately there is actually no evidence that a smiley face can change your attitudes on immigration policy, but people thought it was the case. College football games were supposed to determine the outcome of the election, and this is based on the popular voters are idiots theory of political science, which is that if your local team wins the football game, then you're happy, and since you're happy, you vote for the incumbent. Not a lot of evidence for that one either. Shark attacks also have this for you here. Yeah, so there was a claim that shark attacks determined the 1916 presidential election. This is another iffy one. I'll get back to that. I want to start with a happy story. This is a study that somebody mailed to me a couple of years ago. I think they expected that I would make fun of it, but I actually liked it. It was a paper called Influence of Valentine's Day and Halloween on Birth Timing. Here's the data that was used in the paper. They had the number of babies born every day over, I think it was an 11-year period. And they're plotting the total number of babies born each day. This heart here is Halloween, and then they have the days the week before Halloween and the week after. No, this is Valentine's Day. The witch is Halloween, of course. The heart is Valentine's Day. They have different sorts of births. You see more births on Valentine's Day and fewer in the week before and the week after. You see fewer babies born on Halloween and more the week before and the week after. Now, just in case you're wondering, that the theory here is not that like Halloween is so scary that the baby's afraid to come out. The theory is that a lot of births are scheduled, either induced births or cesarean sections, and they're more likely to schedule births on a happy day like Valentine's Day, and less likely to schedule the births on a negative day like Halloween. Now, when I saw these data, I found it interesting, but I was a little bit worried because you're only looking at 30 days out of the year, and there could be all sorts of patterns that we're not otherwise seeing. I wanted to see all 366 days. So here's the full time series. Ignore the curves. And this is actually also a slightly different data set. I think it's data over a 20-year period. You see fewer babies on New Year's, July 4th, Christmas. The day before Christmas has fewer babies. You see more babies on December 30th, which might sound a little odd, like what's so special about December 30th? But then you realize that the baby has to come out somewhere. So if the baby's not being born on Christmas or the day before, and it's not being born on New Year's, you have to have some days with extra birthdays to counterbalance that. Here's Valentine's Day, and here is Halloween. And in this graph, it's not completely obvious that these patterns are real, because although you see a jump on Valentine's Day and a drop on Halloween, you also see a zigzag pattern. There's about 52 of these cycles during the year. And the reason for this pattern is that the data are not an exact 28-year cycle. So there's confounding of date of year and day of week. And we already know fewer babies are scheduled to be born on the weekends. So we need to do a little more. We need to decompose the data a little bit. Here's a very pretty graph somebody sent me, showing me the, it's a heat map showing which dates have more birthdays. And it's a very pretty graph that I just hate. I think it's horrible. Maybe it's kind of great because it allows you to compare what's happening on the 22nd of every month, but I don't see why you would want that. You can also see there's more births during these months out of the year, but you can see that pattern much more clearly in the time series. I just wanted to share this with you because although it looks pretty, it's kind of useless. One way I like to see that is that I see graphs as demonstrating comparisons. This particular graph allows you to compare the 22nd of every month, but it's not clear why you would want to make that comparison in the first place. This was something a little better my colleague Aki Vetteri made. It's a time series decomposition. We decompose the number of births. We have a slow trend in blue. This is data are from 1968 to 1988 in the United States. There's a slow trend in which there was fewer births for a while, and then there was an increase of births at some point during the 80s. There's a fast non-periodic component because different things happen at different times. There are events that make it more or less likely for people to decide to have babies. And then 9 months later, you see more or fewer babies. We have a day of week effect, fewer babies born on the weekends, and that effect has increased over time. If you look carefully, the line for 1988 is steeper than the line for some of the earlier years. We see a seasonal pattern, more babies born in the late summer because more people are having babies in the late winter, or in the midwinter, I guess. And then finally, we have special day effects. Now, to estimate the special day effects, we did not specify saying we're looking at Valentine's Day or Halloween. We just put in all the days of the year. And we also had to hard code in Thanksgiving, Memorial Day, and Labor Day because they're floating days. So they were coded separately. Other than that, we just put in all the days of the year and let the data sort them out and discover what they could discover. And there you see the drop on Christmas and New Year. And if you look carefully, you do see it go up on Valentine's Day. You see it go down on Halloween. So it was possible to find that. We refit the model now. This is the same model fit to data from 2000 to 2014. And you see similar patterns. The amplitudes of the fluctuations are bigger. So now you see that Christmas now has only 50% as many births as some of the days before and after. I'm going to go back for a second. In the 1960s, 1968 to 1988 data set, Christmas was at 80%. Now Christmas is at 50%. That's because there's a lot more scheduled births than used to be. Now I have more things there's more I could talk about this example, but I'm going to stop here because I want to get onto the crisis in science. I'll show you one more picture. This is a blow up of the last graph. Here's Valentine's Day, here's Halloween. We circled the 13th of every month. If you're careful, you can see that too. There's a lot more in the data if you keep looking. Now, what's the message from this example? There's a principle in statistics we call the blessing of dimensionality, which is that if you have more information, you can learn more. If your problem is more complex, you can learn more. In this case, when when we just looked at 2 days, 2 special days out of the year, you could see some interesting findings, but there's a nagging question of, should you really trust the result? Should you worry that there is some sort of data dredging? It's hard to contextualize. What's so special about Halloween and Valentine's Day? When we look at all 366 days together, we see a big picture and everything makes sense. So the alternative is the problem. So I gave that example of something that we did that I like. And I think the alternative that causes so many problems is the norm in science, which is to study one thing at a time. So just for example, well, this was a famous example from 3 social psychologists. They did a study, it's called the 50 Shades of Grey study. Participants from the political left, right, and center completed a perceptual judgment task. And the idea was that people who people who are political moderates perceive shades of gray, whereas people who are political extremists saw images as being more black and white. That was a kind of dramatic study that will get you into the tabloids and into the New York Times. And if they had played their cards right, probably they could have got a TED Talk out of it. They're very excited about it. They decided before publishing to replicate their study. They did a pre-registered replication, which was supposed to have 0.995 power. It's supposed to be a 99.5% chance that they'd find a statistically significant result. And it vanished. And this is pretty amazing. They're actually trying to replicate their own study, and it didn't replicate. Now, one possibility is that they just had really bad luck. They had 0.995 power, but 1 in every 200 tries, things go wrong. But I think a much more reasonable explanation of what happened is that they didn't actually discover anything the first time, that they had they saw an exciting pattern in the data, but that's because they'd been primed to look for something exciting, and they looked at the data hard enough until they found something. It was very admirable that they replicated their study and they reported this. Here is another example that I mentioned earlier, was the study published in the journal Psychological Science that claimed that during certain times of the month, women were more likely to vote for Barack Obama or Mitt Romney. And the argument being made, the argument was that during a certain time of the month, women are more sort of female, and Obama was a candidate who was favored by women, so there was some way in which they would expect that during that time of the month, women would be more Obama voting. The data didn't quite turn out that way, though. What they actually reported in the paper was an interaction, where single women were more likely to be Obama supporting during a certain time of the month, and married women were more likely to support Mitt Romney. And you could sort of come up with stories about this too, that somehow Mitt Romney was a kind of guy who would appeal to married women. He had 6 kids, and he was just the kind of guy who a married woman would like. So during a more fertile period of the month, they found him more appealing, whereas single women were maybe more likely to support Barack Obama, because after all, Obama was he was more of a young person's candidate. He was actually himself younger. He was kind of dangerous. He was a foreigner. All these things. When I give this talk live, I have to say that people laugh at that when I say he was a foreigner. But you can't hear that here, so I've had this prepared. Okay, so let's try this again. Barack Obama was kind of a dangerous candidate. That he was a foreigner. Okay, yeah, that's better. That's supposed to be. Okay. We have to work on this webinar thing. I think we're going to have a live laugh track next time. But in all seriousness, there was the issue with this study, which was, again, this was published in a top journal in psychology, was that it's a very flexible hypothesis. They didn't find a main effect, but they were able to come up with a convincing story about their interaction. And I have a feeling that had the interaction gone the opposite direction, they also would have been able to explain it. because then they could have said how single women support Romney because single people can support a conservative because they're freewheeling, whereas married women maybe would support the liberal because, after all, they're more interested in nurturing and caregiving and so forth. You just come up with story after story after story, and you will get them published. But to get them published, you need one thing. You need statistical significance. So we'll talk about that next. I want to say that I'll get back to this point that these sorts of studies are dead on arrival, which what I mean is I could tell even before they did this study that the data would not be sufficient for them to answer their questions. Here was another one. Does body language shape who you are? This was a popular study, said to be the second most popular TED Talk of all time, claiming that if you hold your body in a certain way, then certain good things will happen to you. This was this was their estimated effect. On the left, you have their confidence interval for their effect size from their study, which excluded 0, meaning it was statistically significant, meaning it got published in the top journal, meaning the authors became famous. Some other people who are less famous decided to replicate the study, and the replication was right here. I want to take a hard line on this one because at this point, I think the one problem with science is that there's too many nice people out there. And I think a lot of people have this thing, they'll see this, even the authors of this replication study. You have the original study and it's wide interval. There's lots of problems with it. The replication is, nothing's going on. So there's a temptation to kind of split the difference and say, well, it looks like the effect happens in some places than not others. Or it looks like maybe there's some differences between the study, or maybe we should lower our confidence in the original study. Maybe it's not. Maybe we should be a little suspicious. This is kind of attitude. So I have a trick that I do when I look at studies like this, which is I do what's called the time reversal heuristic. Logically, it should not matter which of these two studies came first. They're both just studies, right? They're just they're experiments. So imagine the second study came first. The second study was a pre-registered, carefully designed study, and in that study, the data were completely consistent with no effect. Then there was a replication. So consider the original study to be the replication. Somebody found, so imagine this. There was a study that was done finding no effect. It was very careful. Then some other people decided to replicate it. What they did was they replicated it, but they had 1/5 of the sample size. They had sloppy measurements, and there was no pre-registration. So they were free to look at any outcome they wanted. After doing that, taking the data from this study, so in their study, what they did was they were free to find anything, and so they found something that was barely statistically significant. To me, that's not impressive. That's zero evidence, not evidence of anything at all. So when I see these two studies, I don't say, oh, well, here's one thing that found something, here's something else that didn't. The truth must lie somewhere in between. Let's be open-minded. I mean, sure, I'm open-minded. I'm open-minded enough to have the belief that this effect is so small and variable that no study of this size would ever detect anything. But then this comes to a bit of a puzzle. That's what we like to say in political science. Like we always like to have a puzzle, right? So one puzzle is how come people keep doing studies that then the replications fail? And then second is if the replications are failing, how come all those studies look good in the first place? And that's the topic of the talk. I think I only have like 4 minutes left though, so I don't know that we'll actually get to my talk. the pre-credit sequence was.
Andrew, you can take up to 14 more minutes.
Okay, 14 more. Okay, I'll work on that. Maybe this was the study of the fat arms and political attitudes, but I guess we could maybe maybe we can skip that one. Skip the fat arms. The social. don't know, maybe I will talk about the fat arms. So this was a study, The Ancestral Logic of Politics, Upper Body Strength Regulates Men's Assertion of Self-Interest Over Economic Redistributions. So the funny thing about this is, I won't say that almost every word in the title of this is wrong, but there's a lot misleading here. First, this was a study, well, there were 3 experiments, but most of the study, 2 of them were on college students. So when they talk about men, they talk about male college students, which somehow doesn't sound as great, maybe. They actually don't have any measures of upper body strength. They measured arm circumference. That's why I call it the fat arms study. They compared, they ran a regression, and they looked at how the arm circumference of male college students predicted their attitudes on economic redistribution. And what they found was that men with fatter arms opposed economic redistribution. So the idea is that if you have fat arms, that indicates your strong upper body strength, and then men who are stronger are more, they favor the strong, and so they don't like economic redistribution because that's favoring the weak. And so the idea is this popular idea in social science that we're all just a bunch of baboons and we don't realize it. Now, there are a few problems with this study. So as I said, the first thing is they have no measure of upper body strength. But there's more than that. They did not actually find what I just said that they had found. They didn't find that stronger men or men with fatter arms are more likely to oppose redistribution. They found an interaction between upper body strength and parental socioeconomic status. So the idea was that fat-armed college students with rich parents were more likely to oppose redistribution, but fat-armed college students with poor parents were more likely to support economic redistribution. But then they argued that's all about self-interest. So if you're from a poor family, then therefore self-interest is it's in your self-interest to have redistribution. So the argument was that even so, fat-armed men are still more in self-interest. But it's kind of a weak argument, for one thing, given that college students in general are generally upper socioeconomic status. Also, there's a big degrees of freedom problem here because they interacted with parental socioeconomic status. They didn't interact with marital status. Well, there aren't that many married college students, but that was what was used in that other study of the women. They didn't interact with number of older siblings, which is sometimes used in these evolutionary psychology studies. They like to interact with that, or your birth order. They didn't interact with outdoor temperature, which was a variable used in a different controversial study. Okay, there's a bunch of other things they didn't interact with. So they really got to pick what they studied. And as a result, they were able to find something statistically significant, which fits into their story, and it fit into their men or baboon story, but just about any data would fit into this story. Again, my problem, one of the things is when I discuss these studies with people, I don't typically give them the recommendation. Like when people do a study like this, I don't usually say, oh, you should pre-register your study, or you should have a bigger sample size. Like, I think these studies don't really have a chance. It's so indirect. Like, you're just looking for these sorts of patterns. There's so many patterns that you could possibly see. And I think either you have to have a clearer story of what's going on, or else I think you have to study more things. You can't just study one issue. You could study many political issues and many characteristics of people, fit a big multi-level model, like we did with the birthdays. By picking things out and then publishing papers like this, you're just getting noise. And also it means you can't even do a meta-analysis of the literature, because the literature is just a bunch of selection artifacts. I'll skip the famous study of social priming. I have some funny quotes, but maybe it's not worth going on. This is old stuff now. This was actually from a couple of years ago now, but the journal Psychological Science sends this thing every week about what they've been doing, what's come out this week. I took 1 week of them and I listed all the articles they had: turning body and self inside out, visualize heartbeats, alter bodily self-consciousness and tactile perception, aging 5 years in 5 minutes, the effect of taking a memory test on older adults' subjective age, the double-edged sword of grandiose narcissism. That's not really relevant to us anymore in politics, I suppose. They have a whole bunch of these studies, and each of them has this problem that it's this like outdated method of science. This is social science. It's supposedly focusing like a laser beam on a particular question, and I think this is a bad mode of social science. It's like the clinical mode of social science. The idea is you have this experiment, you give half the people one pill and half the people the other pill, and then you see who lives and dies, and you look at that, and that's the effect of the pill, right? So this is what we teach in statistics textbook. You want to learn something, you do this very focused study. You do a survey, you do a randomized experiment, you do an observational study, you ask this one question, and you try to zero in on it. And I think these are examples of that, and I just think it's a disaster. These are goofy questions. You look at the data here. Okay, you look at the data from these studies. They're tiny samples. They're not representative samples, with two exceptions here. They're all just these little things. And again, you have to unlearn this attitude that like you can bring in 30 people into the lab and learn some deep fact about human nature. It's hard to do that. I can't say you can sometimes learn deep facts of human nature from 30 people. You can learn deep facts of human nature from one person. But if you want to learn deep facts of human nature from 30 people, you need to study effects that don't vary a huge amount from person to person. It's not enough. You can't just say, I'll look at anything, and then I'll look at any outcome, and then whatever is statistically significant you report. That creates all these problems. We talk about the multiverse. This is the ovulation study that I mentioned before about women voting. The multiverse represents all the studies that you could have done. So in the particular study of ovulation and voting, we listed a bunch of data coding choices. They asked the women in the study in different ways. When was their last menstrual period? How sure are you? Based on the ways that these questions were asked, there are different ways that the data could be classified. There are different ways there are different natural ways that you might consider throwing away subsets of the data. And indeed, in the literature, different papers in this literature use different data exclusion rules. There's an assessment of which was the last date, and there are different ways of coding that. There are multiple ways of coding, of labeling which are the most fertile days of the monthly period. And finally, the relationship status. I think I told you that they had an interaction of single women and married women. Then what about people who are neither single or married? You're living together, how do you code that? There are different ways of coding those. If you take all these choices, you get 168 possibilities. We took the data and we reanalyzed their data using all the 168 different ways you might have analyzed it. And this graph shows different confidence intervals. They did multiple analyses. This was the results from one of their analyses. We also did other stuff. This particular analysis, the blue line is what they actually reported, and these are the other 167 things. Now, just to be clear, I am not saying at all, I don't think they did 168 analyses and then reported the blue one. I think they did one analysis of the data. However, I think their analysis was informed by the data. The data come in, you see things, a certain person, like her response doesn't make sense, you throw her out, it doesn't fit the story. Another case, you say, well, this is okay, you exclude it or include it. Once you have these, you're free to exclude or include data like that, that's what happens. It's hard to control yourself from doing that, especially given all the rewards that you get from getting statistical significance. You can also look at all the different p-values. This is a histogram. The star, that represents the p-value they found. These are all the other p-values from the other things. You won't always see the p-values uniformly distributed from 0 to 1. You can see all sorts of distributions. But this is what happens, again, when you select through your data. I'll skip this. We're getting near the end here. Practicing what I preach. I won't give you the background, but this is a research project I'm currently involved in. And I just want to say we had, I think there were 14 or maybe it's 16 different things that we were looking at here. And we ran a bunch of regressions. We looked at the data in different ways. And I'll tell you, although a lot of these confidence intervals overlap with 0, I think the data are they're not consistent with a total 0 effect. I think there's something going on. But I would say that in the past, I might have focused on the 4 things that were statistically significant. And it's not like I'm obsessed with significance, but I might have said, okay, well, we have evidence for these 4. Let's talk about these 4 things. And then sort of understated the variation. And now, having looked at all these things, I realized the mistakes that you can make by pulling things out. I think you have to look at everything at once, and you have to be careful not to just pull things out. So I just wanted to say this because it's not about me criticizing other people, making fun of people or whatever. It's changing how I think about research. I'm not worried so much. I don't think I'm studying null effects. I mean, but I do get worried that I can be chasing noise, and I have to be open about the fact that effects are small. That's an important part of what I do. I have an example related to policy, but I'm running out of time, so I'll skip that. I want to conclude here with this slide again about the smiley faces and the shark attacks. And what I want to ask, I want to set data aside and say, I'll just say that these studies have lots of problems, but I want to ask the question in red, what if it were all true? Imagine a world in which your political attitudes were determined by what time of the month it was, how much you could bench press, whether somebody had sent a message to you below your limit of conscious perception, whether your favorite sports teams won any games lately, whether there was irrelevant news in the newspaper that month. Now, what if these things were all true? It's very hard for me to, well, first, it would be kind of a scary world, but also it's hard for me to picture how this all could be true. Like, how could it be true? I can imagine, okay, like people talk about the butterfly effect, right? So there's a butterfly flapping its wings over here in China, and then, you know, that causes some strange thing to happen in the United States because everything in the world is connected. Now, I can accept that, like the world, things are connected and life is unpredictable. These kinds of claims are not like the butterfly effect, because they're not just claiming that, like, a football game could affect somebody's vote somewhere. They're claiming systematic effects. So they're claiming predictable effects. And I don't think you can have all these predictable effects occurring at once. I only get one vote. And it's not clear how all these things can have large effects. It seems to me actually kind of mathematically impossible. So that's yet another problem with studying influences one at a time, is that you really come up with an incoherent view of the world. And I'll just conclude by saying that as a political scientist, like, if it were true that our political attitudes were so strongly determined by these things, I'd like to know it. But if it's not true, then I think that psychologists are making a big mistake by promulgating this, I think, false belief about where our attitudes are coming from and how they're influenced. So that's enough from me. I'll answer your questions now.
All right. Thank you, Andrew, for that presentation. At this point, Andrew Gelman is available to take questions from the audience. You can email questions to methods.colloquium@gmail.com. You can also ask a question using the Zoom Q&A button that appears at the bottom of the webinar window. For our viewers outside the United States, we recommend using the Q&A box to ensure that we receive your questions immediately. And we already have quite a few questions, so I'm just going to...
Wait, I just want to say one thing. Next time you do this, I think you should keep your image on there, because if I were talking to you, even if I just saw you laughing at my jokes, that would it's very hard when it's completely blank. It's just like, it just completely throws off.
I admit my reason for turning myself off is selfish, because that means I can take notes or whatever, and no one's looking
I
at.
can take notes, that's fine. It's just like, it just completely threw off my timing. And so like, for next time, I'm just saying you should do that. Like, take notes, but just still be there. It's like talking to a person is much better than just.
All right. We will definitely consider that. But I want to get to the questions because we're running out of time. So an anonymous viewer said you might want to clarify for non-U.S. participants that Al Gore received a majority vote but actually didn't serve as president due to the Electoral College. I guess that's more of a comment than a question. Okay, so Longtran asked.
Al Gore won most of the votes in Florida too that year, so it wasn't just the Electoral College, but
he definitely wasn't president. Yeah. Longtran asks, the cases that you touched on both in this talk and on your blog tend to be in the social sciences. So do you think there's a similar situation in the natural sciences? Because it's hard to think about this problem without thinking about the long-held criticism that social sciences are soft and deserve less respect than the natural sciences.
Oh, well, I do think we deserve less respect than the natural sciences. I mean, social science is very important, but it's just, if you think the natural sciences, they've done sort of amazing things. Like they've come up with amazing materials like ceramics that are so strong. They build bridges. They put rockets on the moon, and social science is like, we're still like trying to prove that like discussion works better than lecture in a classroom and so forth. So I think natural sciences are much more advanced than social sciences. But of course people are pushing natural sciences towards the junk science frontier. I mean, there are areas like, MRI scans, where people have all these problems, where they make all sorts of dramatic claims that aren't proven, gay gene hype, stuff like that. So a lot of it's moving in that direction. But I guess the strongest natural science is much stronger than the strongest social science. Let's say that.
I want to follow up with that myself, because it seems to me that a lot of the practices that you had mentioned in the talk and before that you're concerned about are actually very common in the natural sciences. For example, tuning your procedures, tuning your analysis in various ways, sort of adjusting things, not necessarily having a very super strong theoretical expectation going in. Pre-registration is not, as far as I know. My brother is a chemist. I don't think it's a thing.
Okay, here, let me say a few things. So then here's what's happening is that if you have a stable effect and you have low variance, low bias measurements, you can do a lot. So I think science of any sort proceeds well when you have stable effects and when you can measure what you want accurately. Now, if you think of weak natural science, so often that's like, for example, like, medical science, that's natural science, right? So if you have like studies of drugs or procedures and it's not clear whether they're working or not, it's because there's a lot of variation between people, and often the things that are the weakest often are because you don't have good intermediate outcomes and you don't have a good model of the world. So when you have a model and you can measure intermediate steps, then I think you're in much better shape.
There are a lot of questions that are sort of about this general one, so I'm going to read one of them off. And there are many sort of things that are along the same line, though. So an anonymous viewer asks, it seems like many of these issues are structural, which is to say that the scientists do these things because the academic system rewards them to do so. It's not just a lack of statistical knowledge. So what are the institutional changes that we can make to address these problems?
I have a lot of thoughts on that, but I don't know that I should talk about it, because like, what do I know? I mean, I just have my life experience on that. I'm not an expert on designing institutions. Like, I have my pet idea is that journals should become recommender systems, so that like the APSR, they're basically all political scientists should be able to post stuff on SSRN or whatever whenever they feel like it. And then what would happen is every 3 months there's something called the APSR recommender system, and the APSR recommender system lists like 20 papers that they like, and they get reviews, and they just publish the referee reports right there, and they say, these are papers we like, and these are some concerns. I don't see why they need to do typesetting and all that. So that's my pet solution, but I just feel like I hate to sort of yammer on about that because I feel like I don't know anything about it. It's just yapping, you know.
This is something, Chris Johnson asked this question, and it's actually similar to one that I wrote down myself. Is there an objective way to assess the reasonableness of mechanisms or otherwise test a mechanism before performing research? Maybe raise the bar if the mechanism seems ridiculous. And my own spin on this is, what a methodologist often wants to do is make a magic widget or test or something that solves the problem, right? I'm skeptical if that's possible, but I wonder if you think that there is something we can do to cut some of these things off.
Well, yeah, I do. I have an idea. So John Carlin and I wrote this paper. We published it in a psychology journal a couple of years ago, where we talked about type M errors and type S errors. And we promoted the idea of, we call it design analysis, but it's like a power analysis. And in the paper, we talk about how even after a study is done, you can do a design analysis and find out that this study was useless. It never had a chance of working. I think before you do a study, you can do a design analysis also. Now, the problem is that traditionally it's called a power analysis, and it goes like this. You take an estimated effect size, and then you have your sample size, and you figure out your probability of getting statistical significance. There are two problems. One is the effect size tends to be overestimated because you're pulling it out partly from optimism, partly because you're pulling it from the literature. The literature is full of statistically significant estimates, statistically significant effects. Statistically significant effects are overestimated by definition. They're biased estimates because they have to be at least 2 standard errors away from 0. So you start out with overestimated effect sizes, which make you think you have more power than you have. But the other thing is the very concept of power, because it assumes that your goal is to get statistical significance. What if before you had to do a study, before you did a study, you did a design analysis, but you had a more realistic estimate of the effect size? And then you said, what would happen if I do this study? Let's play the game forward. What if I gather the data, and what if I have the rule that I'm only allowed to publish something that's statistically significant? What's going to happen? Well, you're going to find out that you're probably going to have a really dramatic overestimate of any effect size. It's going to be very hard to discover what you want to discover. Sort of like that thing that I showed in my own research, where you have a huge amount of noise, so it's hard to see anything. But I think the advantage of that, I think people are going to say, I don't know the effect size before I do the study, but I think there's a real advantage to forcing people, whether before or after the study, to give a prior estimate or a literature-based estimate of effect size. Commit yourself to it, because then critics can pick on that. Like, they can say, well, I don't buy your result because I don't buy your prior estimate of effect size. And you have to defend that. So you have this kind of discussion. Now, as it is now, I feel like effect size has this very funny thing. It fades in and out. That when results are advertised, you hear all about how this is such an important effect, it could swing the outcome of the election. But when you push people on it, then they retreat and they say, oh, no, it's statistically significant. That's what's important. So I think it's not... Okay, a naive thing people used to say is, oh, don't worry about significance, just give confidence intervals. Effect sizes matter, not p-values. That's naive, because if you report statistically significant results, you're going to have overestimated effect sizes. So a big fat confidence interval isn't so fat it's wider than the screen here. This is as fat as I can show you. A big fat confidence interval is like not telling you anything. I mean, so I think force researchers to commit to literature-based effect size estimates and force them to think about it. Remember that study? There was that study a couple of years ago that was with the fake data that the political scientists did about the canvassing. And one thing we noticed was the effect was so huge. And they were sort of never forced to really grapple with what that meant to have such a huge effect size, because it's just all about, creating results.
There have been several questions along about one thing, and I'm curious about this as well. So Marco Backel asks, I hope I pronounced that correctly, how do you feel that about more classical political science studies with ANES data or large N surveys? And then another person asked, sort of relatedly, You've been talking a lot about experimental studies or quasi-experimental studies. I wonder how this applies to observational studies. And in fact, to follow up a little more on that, you are very skeptical of the clinical model of research, but there is a line of research, there is a group of researchers in political science who argue essentially that experiments are the only things worth looking at because observational data is hopelessly confounded and under-identified. So I wonder what you think about how your critiques apply to observational research and whether experimental research really is better.
Well, a lot of the studies I was critiquing were observational. So, for example, the fat arms and the ovulation studies are observational. They weren't bulking people up or inducing them to have periods or anything like that. They feel like experimental studies because they're analyzed that way. I think experiments are just wonderful. I've analyzed observational data mostly because I'm not actually good at designing experiments. Whenever I've tried to design an experiment, it's kind of a disaster. The data all come out noisy and I can't get much out of it. So I'm not that good at that. Observational data are plentiful. So if you're somebody like me who's actually not very good at designing studies, but good at analyzing data, I use a lot of available data. And so I'm not trying to put down experimental studies. I think the same principles apply. If you're doing an experimental study, I think you want to look at lots of experiments and look at the larger context, and I think that's true observationally also.
Ben Jacques Leslie asks do you have any thoughts or recommendations for interpreting results in social science for policy? I work in a research unit of a state government and try to use social science to make recommendations to policymakers.
You know, I feel like I should have just spoken for 5 minutes and just have 55 minutes of questions. Usually things like nobody ever asks questions, so I didn't realize. Because everyone's heard everything I've said to say. Everyone's heard all that stuff before. So I gave you 40 minutes of stuff you've already heard. And now, I apologize to everybody on that. I'll try to do better the next time I do one of these. I'm sorry about that. I think I'm a big fan of formal decision analysis, and I like to talk about like the idea of there being a paper trail, connecting your assumptions to your conclusions. So I sort of think, not that I've done it a lot, but I feel like it would be good to try to explicitly write down costs and benefits and, write it down like, here's my expected utility if I do this, if I do that. There is a temptation to have like a wall, like they have the wall between the advertising and the editorial in the newspaper. I feel like often people want to have that wall between inference and decisions. So there's like the scientific enterprise that does inference and creates stylized facts, and then the stylized facts get used by decision makers. And I think we just can't do that because the stylized facts aren't really there. And we can't wait for that. And also, I don't want to say, well, we don't know, it's not significant, so we can't do anything. So we have to make decisions based on the information we have. So when I criticize a study and say I don't believe it, that I don't mean that the ideas behind it shouldn't be used in decision making. I just don't think they should be considered as known truths. So my feeling is we should be more explicit about the costs and benefits of different decision options.
I think, if you look at, you mentioned the elections earlier, it's always very dubious to take any one poll, right, and say, I saw a poll, for example, last night that says that Hillary Clinton and Donald Trump are within the margin of error of each other in Texas, right, which is very interesting if you live in Texas. But then I went to HuffPost's poll aggregator and not really, right, that was sort of a weird poll. And I think for a policymaker, either formally with Bayesian analysis or informally, you can do the same thing, right?
Well, yeah, of course it's even worse because at least with polls, presumably most of the polls are sort of something like unbiased estimates of what you're aiming for. But in the research literature, everything is overestimates. I mean, it's all, like almost all the papers you see are artifacts of selection bias. I mean, except for anything that I've ever done, maybe, but like everybody else's stuff is completely. No, seriously though, I think it's at least like poll averaging is pretty easy, but meta-analysis of the research literature is much tougher.
I think we have time for just one more question. An anonymous viewer asked, do you have any comments on Lipton's inference to the best explanation framework? Does this capture your approach apart from fixing the technical statistical issues such as low power and the garden of forking paths?
I've never heard of this Lipton thing, so I can't answer that one, sorry.
Okay, I will ask another one then. I actually didn't know about it either, so I was hoping you did. Dale Lehman asks, medicine seems to be an area while steeped in the traditional sciences that has all of the problems you have identified in the social sciences. The question is why? Certainly there are issues of poor incentives and so on, but does it also result from the way we learn to do science? Do we learn science in an environment where experimental studies of one effect at a time make sense, and then not learn that this approach doesn't apply to politics, economics, medicine, climate change, etc.?
I think medicine has like a couple problems. One is everything's more obscure in medicine. It's much harder to get the data, so it's harder to figure out what's going on. Also, it's in psychology in particular, it's super easy to do replications because psychology studies are cheap. It's much harder to do replications in political science. It's not like we can say like, let's get 10 more wars going, you know, and then we'll have enough data. You know, so in economics, similarly, you know, 10 more recessions, it's not going to happen. But I think also medicine has a couple other, like there is a lot of medicine, like, you know, they can cure leukemia and they didn't used to be able to do that. But if you look at the way they do that, they didn't figure that out by like taking a bunch of different treatments and just trying them on people and seeing what was statistically significantly better. They have lots of intermediate measurements that they do. And I do work in pharmacology. And again, we have lots of intermediate measurements. The paradigm of medicine that doesn't always work so well are either these epidemiology things or like the cancer cure of the week that like cured cancer in mice and, you know, was in the New York Times and it never cures anybody. And often, like, you know, there's just variations. So things work in some species and not others, and some people and not others. So I think variation is a big part of it right there, and that it does share with social science.
All right, well, that's all the time we have for this week's IMC. Next week, I'm going to tell you about a talk we're having at October 21st at noon Eastern Time. We will host a talk by Sarah Boucher of the University of Wisconsin at Madison entitled Engaging Experts Dealing with Divergent Elicited Priors in Political Science. You can check out our website, www.methods-colloquium.com, to get more information about this talk, and you can also see the rest of our schedule for the 2016 academic year. Professor Gelman, I want to thank you so much for appearing on today's webinar. There were lots of questions. I apologize we can get to them all, but thank you for coming.
No, I just feel terrible. I should have talked for just 5 minutes, but it's too late now.
I had a good time. I hope you guys did too. So I'll see everyone next week. See you later, Professor Gelman.
Okay, bye.
Okay.